If you've used C or Java, you're used to the idea that there's two levels of your language. There's statements and there's expressions. We're going to be looking at languages that don't have this distinction, and so it's useful to sort of analyze it in the context of a language you know. When you see a program like this one, you can immediately ask yourself, well, is this C? Is it syntactically valid as a C program? And one way to ask that question is simply to type it in and see if a compiler will take it. So let's ask GCC, is it C? And GCC says, yes, that's C. And just to show you that I'm not faking it, let's try something that's not C. And if you have a program that's not C, the compiler will let you know. It's like, I'm sorry, whatever you've typed in, that's not C. So, but this is. And what is it doing? Well, it's just going to, this function returns 1 if x is non-zero, and it returns 2 otherwise. So you can sort of see that if we run it with 0 as the argument, we'll probably get out 2. Okay, so anyway, so that's what the program does. Yay, it's a fantastic C program. What about this? Is that C? Could be. You could type it in and see what happens. So essentially, what are we doing here? Well, you note that the two sides of the conditional are both assigning y. So why don't we just pull that out so that the assignment is now shared by the two sides. And if you then ask C, hey, is that legit? C says, no, that's not okay. Why not? And it gives you this message which says, I'm expecting an expression. What you gave me is not an expression. You gave me a statement. Now, the authors of C noticed that this was a defect, and they said, well, we need to have the ability to have an if statement. At the time, they were limited in the ability of the parser and the speed of the machines available, and so they made a distinct form for the conditional in the expression language. So the way you write it is this way. So if x, then 1, else 2. And that is C. So C has the ability to do conditionals in the expression language, but it's a different syntax than the conditional in the statement language. If you actually look at the output of the compiler, you'll see it's identical in these two cases. It's very similar, at least if you're optimizing. And the reason for these two forms is purely an artifact of history. There's no good reason for it. So this is known as the ternary operator in C because it's also called the query colon. So query and followed by the colon. And it takes 3 arguments. So it's in a mix-fix syntax. So the 2 parts are spread around the 3 arguments. So it's the only operator in C that takes 3 arguments. What about this program here? What is the programmer trying to do? Well, y here is going to be the result of this. So what is this meant to be? Well, initially we set z to 0. While x is greater than 0, we're going to decrement x and increment z. And then the result maybe is z. So what this is essentially doing then is copying x into y. It's just doing it inefficiently. So counting down, counting up. Not only is this disallowed by the compiler, but also there is no way to express this program in the expression language of C. So in this case, if we want to express the program, we genuinely have to use statements. So what are these things? And why is it this way? Early languages were statement-oriented. So the statements of the language changed the state of the machine. Expressions were added later, And the purpose of expressions was always a little fuzzy, but more or less the idea was that statements were going to be changing the memory and then expressions shouldn't. But in fact, this distinction doesn't hold. So to talk about this a little more accurately, I'm going to introduce some terminology, which is the distinction between a pure expression and a side-effecting expression. Everyone agrees on what mathematical functions do. And what mathematical functions do is they take arguments and return results, and they don't do anything else. So something that behaves like a mathematical function is called a pure expression. It doesn't do anything else. The other kinds of things that it could do are all side effects. So these are, for example, assigning visible variables in memory, changing or jumping around in the control flow, printing out to the monitor, etc. We have pure expressions, of course, in a language like C. We have, the literal expressions, we have operators, we have function calls. And in the statement language, we have things that change control and which update memory, we think. So we have return statements in C, we have selection statements like if then else, we have iteration statements like while. But a weird thing about C is that assignment actually doesn't happen in the statement language. Assignment happens as an expression. So this is actually an expression to take the count to be count plus 1. And in C, the syntactic rule is any expression can be followed by a semicolon, and that counts as a statement. So you can see this by doing some sort of unconventional things in C, like that right there. You might think that that's not a great program. And in fact, I get a warning here that the expression is unused. But note that's a warning and not an error. The reason we have expression statements is because C is full of side-effecting expressions. And in particular, all of the assignment expressions are side-effecting. So here is the increment expression and the assignment expression. Note that the assignment expression in C returns the value being assigned, so we can use it multiple times. So this expression here sets y to be 5, and then sets x to be 5 as well. The mixing of these expressions can get quite confusing and can cause a lot of stress and anxiety for programmers. It's generally considered bad practice. So an expression like this, like what is it doing exactly? So it's probably going to add 5 into y and then subtract the resulting value of y from x. And I believe that's what it does do. It's difficult to determine what is a side-effecting expression in C because functions can include side effects. So here's an example where I have a function that updates a global variable. So let's see, what would we expect here? We'd expect 0 to be the result of the first call to post increment. So note that the post increment here is happening after the return. So we expect 0 and then 1. So we can try this out and see if we get what we expect. So I'm expected to be 1. See if that's true. Indeed, that's what my computer is doing today. So we could also do a pre-increment here, and if we did, we'd expect to get 1 plus 2, which of course would be 3. Indeed. In addition to having the ternary operator, C also has a comma operator. It turns out that in some cases, the authors of the language thought it was useful to have the ability to have a side-effecting expression sequenced after another expression, or rather before. So the operator here, or the general form, is I can have a sequence of expressions separated by commas The first several expressions are executed for their side effect, and then the last one is going to be the result. I had to look around for a while to find the reason for this in C, and it turns out that it was added for expressions like this, or statements like this, where I have a use of read string. So there's several functions in C that don't have useful return values. So read string, I believe, returns void. So what they're trying to do here is read in a string and then determine whether or not they've read in a string of a certain length. So while I read in a string and have a length of that string, then continue to do something. Writing this without the comma operator requires two separate calls to read string, one before the entrance to the loop and then one at the bottom of the loop when you go back around. So by having the comma operator, they can collapse that into a single instance of the call to read string. We can sequence both in the statement language of C and in the expression language of C. It's not very common to see this. You'll see the ternary operator much more. But just to let you know that it is possible, and we'll be doing it a lot in Scheme. So in summary, C has several features in the expression language, which we also see in the statement language. The ability to sequence multiple expressions, the conditional, using the ternary operator. But the expression language in C is still impoverished. We don't have the ability to declare variables. Do we have the ability to do loops? Well, the only way you can do that is by writing recursive functions. So, and that's actually the normal way to do looping behaviors in a functional language.